We multiplied it and divided by 2 so that the angle and denominator are exactly same. Once the angle and denominator are exactly same, we can find the limit, which is 1 as x approaches 0, or as the angle approaches 0. Angle and denominator, they approach 0. Sometimes it happens that limit is not found. Let's say we have limit x approaches 0, 1 over x. I cannot simplify 1 over x further. There's nothing I can do with this. So all I can say is I can plug in 0 in the denominator, but this is not possible. In some of the books, they all actually put this value in and say that this is infinity. That's also correct. But normally we don't divide by 0. So if you're getting a thing that you cannot get rid of, you cannot get rid of a 0 in the denominator, you'll say that limit does not exist. Limit does not exist. Same way, if we have limit x approaches infinity, x square plus 1 divided by x. Now this is of the form px over qx. The dominating term in the numerator is going to be x square because that's the higher degree term. In the denominator is going to be just x. You can cancel one power, so this becomes infinity because there is nothing you can do now. Again, you'll say the limit does not exist. Limit means a finite value that a function takes on a particular value of x. Maybe when x becomes very large, maybe at some other point, not necessarily at x equal to infinity and 0 always. It may be some other point as well. So if you have this thing, infinity or divide by 0, it may be negative infinity as well. In all these cases, the limit does not exist because it has to be a finite value. There's nothing else you can do about it. Now, let's try to take a look at another example. Let's say you have limit x approaches 0, x squared over 1 minus cosine x. Now, this thing seems strange because we haven't covered cosine x formulas. But we know what is sine of x. What is x over sine x? I can write this thing as x square over 2 sine square x over 2. And here we have the limit as x approaches 0. When you have trigonometric functions, limit involving trigonometric functions, you have to be on your toes with the formulas, because if you don't know your formulas well, there's going to be a lot of trouble. So it's better that you learn about these formulas, and you should be very comfortable with them. Alright, so what next we can do? Now this thing looks same, except the angle and the denominator is not same. But where is the denominator? Well, the trick here is, what you can do is you can write it like this: limit x approaches 0, x square over 2 sine square x over 2 can be written as limit x approaches 0, 1 over 2 sine square x over 2 divided by x square. I took this x square below 2 sine square x by 2. I hope this thing is clear. I took this x square and I put it in at this place below 2 sine square x by 2. Now I can see that there is something I know. Now you have a sine x divided by x. The angles are not matching, but that's not a problem. We can always make the angle same. But now I know this form. Now we can find out the limit. Now let us try to find that out. This thing becomes limit x approaches 0, 1 over 2. Again, what we do is sine of x by 2 over x whole square. This thing can be written as 1 over 2 sine of x by 2. Now you're dividing by 2 here in the denominator of this, so I've got to multiply by 2 as well. So basically I have to multiply by 1/2 because I'm dividing by 1/2. So you multiply by 1/2 here and you make a square of it. Now this thing becomes limit x approaches 0, 1 over 2. Now once the angle and the denominator become same, this limit is going to be 1. We know about that. So this thing becomes 1 over 4. Or you can say this is 2. So the limit of this function is coming out to be 2. And the way to do it is you convert it into one of the known forms. We don't know what x square over sine square x by 2 is. We really don't know that. But we know what is sine x over x is. So again in this question I have tried to convert that into something known. If we do that, we are able to solve the problem. This was possible only if you know how to convert from cosine x to sine x. You will have plenty of problems involving trigonometric questions on limits. In most of those cases, you have to apply one of the conversion formulas from one form to another form. So in this problem, first we converted to sine form, then we converted it into one of the known form by taking this x square below the sine square x by 2. After that, everything became crystal clear. We just had to square the terms. We just had to make the angles and the angle and denominator exactly same. We did that here. Once we did that, because the angle and denominator are going to 0, the limit is going to be 1. So whatever is left, we just solve for it. And that's how we got our answer. I hope you understand this stuff. And thanks for watching this video.